Okay, so welcome everybody. So in section 6.2 there, we're going to be looking at optimization problems. And these questions will usually be asking you to find the maximum area or a minimum cost or finding a point on the line that is closest to a point xy. And then you guys make sure you practice these questions and make sure you ask me any questions and don't waste a period away there. And because these are pretty challenging and is often where students tend to drop calculus. Um, so anyways, let's begin. There are multiple steps you need to follow when doing these optimization problems. And so for number one, it's always helpful to draw a diagram and to label the quantities. And then you would set the let equations to represent what each variable represents on your diagram, and then write down your formula for the maximum or minimum quantity. And next, really important, is to link your variables so that your equation only has one variable. And then you would start to look at the interval of the possible values and to understand what the restrictions are. So look at the physical restrictions and what what values don't make sense or it just can't be. And then finally, you would determine the max, and then we would do that by considering the critical points and the endpoints. So feel free to try number one on your own, and feel free to pause the video. And why don't we just read the question first? So number one, a farmer with 750 feet of fencing wants to enclose a rectangular area and then divide it into 4 pens with fencing parallel to one side of the rectangle. What is the largest possible total area of the 4 pens? So again, feel free to pause the video and try it on your own. And if not, then just go ahead and copy down my solution.